this recording.
For me personally, it is the third conference in the series of conferences on industrial engineering and technology management we are doing. Personally, what I found is, just 2 days back I am looking at the 2014 proceedings, and I had a role probably to draft the preface in the proceedings. And suddenly I saw that I wrote there the principles of scientific management given by Taylor, and what he has covered in that particular book subsequently, which are the illustrations that he has given to support his 4 principles of management. Actually, that question was given in our fellowship students' examination, and I am telling them the answer is already in the preface of the 2014 conference proceedings. By the time I came to 2016, I made a paper presentation wherein I said what are the basic principles of industrial engineering, and then subsequently I converted them into a detailed principles of industrial engineering. And in that last conference, I presented the paper title was on machine work study. And this conference also, my paper title is only machine work study, trying to detail a little bit more. So that is one thing. Second thing is, I'm very happy that interesting papers are coming in this conference. Right? And one thing I came across in the morning is on the loading and unloading, let us say in the retail, this one. And somebody says it is average 1 ton per hour. That is around 8 tons per day. And suddenly I remembered the Taylor's famous experiment on the pig iron loading. And what Taylor said, it was 12 tons per average when Taylor has seen that particular thing, and he made it to 47 tons. Now, I don't know how many of us remember, now when we come to the manual material handling, the Taylor has taken it to 47 tons, and today we are talking of 6 tons. So interesting problem to compare what was the world standard at that time and what it is now. Your topic we said changing landscape of industrial engineering, way forward for NITIE. I thought we should take it a little bit forward because the faculty from other institutes are there. So whatever we discuss for NITIE is relevant for the other institutes automatically. In the last conference paper, this is the last line I have written in my paper, that innovations in industrial theory and methods are the building blocks for increasing the effectiveness of industrial departments in the country in increasing in productivity. And we always talk of innovations. We require innovations all around. Please. Right. So I am in this particular, Mr. Krupalani said there will be some fights on the stage, etc. But no, as a faculty member, we are here to learn from them what is the suggestions that they are giving to incorporate in our curriculum. Right? I am not here to fight with them. Whatever suggestions they have given, we carefully listen to them and try to incorporate them. So I have made 5 items which are personally given by me, right? Which are all subsequent to the idea of innovations. The first one is the principles of industrial engineering. Second is functions of industrial engineering. Third is the focus areas of industrial engineering. And fourth is the machine work study. And fifth one is the industrial engineering 4.0. From the principles of industrial engineering, I thought I will put up this particular point. This presentation I made 2 days back. But yesterday, Professor Premwat has really energized me, right? And the point he told, this particular point, he himself emphasized, and he said in IIT Kharagpur it was being taught in all the branches. Some of you will remember that in one of the last things, IIT Bombay Dean was here, and I am requesting on the stage that sir, please at IIT Bombay make sure that industrial engineering is taught in each and every branch. You are an industrial engineering professor and you are now Dean Academics of IIT Bombay. You should take this particular lead. Right? This, as I say, industrial engineering, when you define it as system efficiency engineering, has application in all branches of engineering. Right? The core of industrial engineering, according to me, is efficiency. The core of management is effectiveness and efficiency. You take any book on management, the two things that management says are effectiveness and efficiency. And within that, industrial engineers have taken efficiency as their concern. This is my statement. Statement based upon the all writings of Taylor and subsequent people. So when you say it is industrial engineering is connected to efficiency, it is automatically applicable to each and every branch of engineering. Productivity improvement is needed in engineering systems of all branches, and therefore you have to use it in all branches of engineering. You have to teach it in all branches of engineering. Saying industrial engineering is only applicable to manufacturing is a wrong statement. Industrial engineering is applicable to each and every engineering activity. Wherever engineering is one of these statements said, right? The Stanford, where he talked of that. So wherever engineering is used, you engineering in banking, use it. You want the buildings of banks, civil engineer to construct it, he has to maintain it. Yes, in that particular activity, industrial engineering is automatically applicable. You say computer engineering, any service industry using the computers is using computer engineering, industrial engineering is there. Right? Wherever engineering is there, industrial engineering. Agriculture, you use agricultural machines, industrial engineering is there to the agricultural machines. Next one. Next one. I created the functions of industrial engineering. You see, like in management, there are principles of management, functions of management. I bring the same structure into industrial engineering. There are principles of management, there are principles of industrial engineering, functions of industrial engineering. According to me, productivity science, productivity engineering, and productivity management are the three key activities of industrial engineers. Industrial engineering is engineering plus productivity science. This is my explanation of industrial engineering. Yesterday, Professor Premlothe said, we have misunderstood industrial engineering. In 1994, I joined a student here in 1977. I understood something, industrial engineering. 2 years I studied here, spent some time in career in both industry and academics. I came back in 1994. In 1994, it so happened that I came across a definition of industrial engineering in an industrial engineering journal, which is a journal of American Institute of Industrial Engineers. And the definition accepted by the AIE is slightly different from the definition proposed in that particular journal. Right? Subsequently, in a alumni meeting of this institute, I first sensed that industrial engineering is in problems. So right from that time, I am trying to re-understand industrial engineering. What exactly is the industrial engineering? So now my presentation or my advocacy is industrial engineering is engineering plus productivity. Industrial engineering is not common sense. Industrial engineering is actual engineering. You need to apply engineering based on productivity science. This is what is my this. And I feel engineers are natural managers. You cannot build a dam without managing it. You may be called a chief engineer. This statement I told long back in a program for Maharashtra State Electricity Board, because their accounting officers were complaining, our engineers don't know anything. I said, an engineer is not a manager. He may be called a chief engineer or executive engineer. You could actually call a general manager. It's a nomenclature in the engineering units that you call a man chief engineer, but is automatically, basically a chief general manager. So management automatically follows engineering. When I have to list out the areas of industrial engineering, this is what I thought is a listing. Productivity science, productivity engineering, I put it as product industrial engineering and process industrial engineering. Then industrial engineering optimization, industrial engineering statistics. Next slide. Industrial economics, human effort industrial engineering, productivity measurement, productivity management, and applied industrial engineering. There are 10 focus areas I feel the curriculums must have. Then I want to emphatically state that core of industrial engineering is productivity science related to engineering elements, product industrial engineering, and process industrial engineering, which focus on redesign of engineering solutions are the core of industrial engineering. I have given 10 areas. In 3 things, I would say they're core, and the rest of 7 areas, what they do is they provide leverage to enhance the benefit of core engineering design. How do they provide leverage? Optimization. I provide a basic engineering solution which is then optimized. Without my providing a engineering solution, optimization doesn't come. The basic engineering system used to be created with engineers, then only mathematics will come. When you convert a formula for the engineering system that you are doing, use statistics on the core engineering technique, you bring economics, you want to decide whether I want to buy, let us say, an augmented reality system or not. But there's first of all an augmented reality system. The engineering solution has to come first, then only the additional activities will come into picture. This is what I feel as I read the entire industrial literature, right from the first paper of Taylor in 1895, the piece rate system, to the recent sort of things. I know in between the industrial engineering got a bad name, and industrial engineering got a bad name because the main focus got shifted to manpower element and engineering activity became minimum. Once you said industrial engineering common sense and removed engineering from the industrial engineering, that is where the bad name comes. We need to enhance focus on engineering aspect to increase productivity, and the very fact of industrial engineering indicates that engineering is the core of this particular profession. Right. Now, this is the proposal I am talking. In the work study, we need to bring in a component of machine work study. Why? The work study became a popular productivity improvement method in UK, and from UK it went into ILO, and from ILO it came into various countries because ILO promoted productivity after Second World War, and because NITIE has also got ILO collaboration, we also got this particular thing as the core subject. Now, but what is the problem? In work study, technical aspects got neglected. Why? Because it was based on motion and time study. In America, a book of motion and time study, a popular book by Barron's, was created, and from that book a transformation has come into work study. So this is the point. Now, by name itself, motion study is concerned with the human factor. It is not concerned with the technical aspect. By name itself, it is not concerned with the technical aspect. So engineering content of industrial engineering got reduced because of the primacy given to work study, and there is no other subject in the IE curriculum that covered engineering aspect. People thought that work study is industrial engineering. But there is no other subject which has really looked at the engineering aspect in the industrial engineering curriculum. But what I found is that the method study, which is a part of the work study, the term was coined by Maynard. In 1939 book of Maynard, you see the term of method study. And in 1940, Maynard created a subject called operation analysis. That book is still, you can see it on the internet. But despite Maynard's handbook being very popular, this operation analysis did not get adequate coverage. Then, is another thing, Shigo Shingo wrote a book, Study of Toyota Production System from Industrial Engineering Point of View, but I don't think it has become popular. We still talk about the brand of Lean and the MIT and WOMAC, we take care of that, but we don't really take care of the Shigo Shingo, who said the Toyota Production System is a result of industrial engineering. He beautifully described how, based on a flow process chart, you are going to get the entire Toyota Production System. And what Shingo said, he tried to clarify between the process analysis and the operation analysis. He said process analysis is, you observe how the raw material becomes finished product to various stages. And operation analysis is, at each stage, what a man is doing and what a machine is doing. Right? And for me, when I wanted to explain industrial engineering, industry means effort. Industrial engineering means effort engineering. So when I want to say a machine work study, which is a machine effort engineering, and there is a human effort, and there is human effort engineering, it comes naturally to me in my explanation of industrial engineering that we need to study machine effort and the man effort. I just listed, in my yesterday only I made my presentation, that number of things can be done in the machine work study, like you can talk of whether new machines are available, whether replacement is required, overhaul is required, some improvement of the machine, what are machine accessories, cutting tools, machine speeds, setup procedure. Setup time reduction is what is giving a lean system. So it becomes a part of the machine work study. Upkeep of the machine by operator. Very important at this point to say that Taylor talked of 8 foreman system, and one of the foreman he recommended is a person who takes care of the upkeep of the machines in the shop by the operators. Today we say total productive maintenance. Taylor said it in 1903. And he said the foreman should be there who is going to help the workers or monitor the workers that machines are properly taken care of. Then breakdown analysis and the machine data generation. We add now the industry 4.0 opportunities of machine improvement, OE analysis, Pakayote, power consumption. The last one, flow process chart equipment type. If you go back and see the work study book in the flow process chart, it is written that you can make a flow process chart for man, you can make material, and you can make it for equipment. But unfortunately, there is no example on the equipment. You see any work study books, they will write only 3 are possible, but equipment charts were not made. We need to recognize this and try to make use of the flow process chart equipment type. We need to define the questions which we are going to ask in that particular thing. So number of tasks can be done under machine work study and productivity improvement of the machine. Now I come to the 5th point I have written, industrial engineering 4.0. So I thought of suddenly that everything is coming as 4.0, industrial engineering 4.0 can also be there. I thought I will coin the word first time, but when I went to the internet I found that in Germany already they had a seminar on industrial engineering 4.0. Right, it's there. So the industry 4.0 was also coined by the German people. Industrial engineering 4.0 was also coined by the German people. Only thing I could not get English translation of what they did in the seminar so far. Right? Now, what I would say industrial engineering 4.0 is productivity science and engineering in industry 4.0 production systems. Now, I said sometime back 10 focus areas. I created applied industrial engineering. It is there in Pankaj Agarwal's presentation somewhere. Applied industrial engineering is there. And according to me, applied industrial engineering is application of IE methods and techniques in new technology. Each time a new technology comes, IE needs to be applied to the new technology. So an industrial engineer doesn't fear new technology. If new technology comes, it's a new business opportunity for him, or it is a new engineering opportunity for industrial engineers. Right? Now what I created for industrial engineering 4.0 is that if an industrial engineer has to successfully contribute to the new technology, these are the stages through which we have to go through. The first one is we should recognize that new technology is there. That's what we all know now. Industry 4.0 is there, right? That's done. Second thing is explore. I myself have to learn what are the new technologies. I don't know. Somebody else created the new technology and I have to know that new technology now. Right? Then I have to analyze. Analyze is the productivity analysis. What are the productivity implications of the new technology? Then comes the develop. Can I develop any productivity solution? Can I create any productivity engineering for the new technology? And then optimize comes, or optimization. But it comes only after I do my development, which is engineering activity. I do it, then comes this particular thing. Then participate. So somebody is telling, right? It is teamwork. Manoj Tiwari is telling, Professor Matthew has shown, it is not a silo sort of a thing. Industrial engineer has to collaborate with others. That's what I put that as a participate. And then comes install and improve. If you see what is our definition yesterday and today, design, improve, install. I put the same definition in this particular framework. The last 2 stages are install and improve, and all the 6 stages are the design. To design the productivity design, you have to go through 6 steps of explore, analyze, develop, optimize, this one, and then comes our install and improve. Now comes what should we do? As an industrial engineer, even I myself, what should I do? Then somebody gives a lots of new technologies. Industry 4.0 means a set of technologies. So 16 technologies is what we said in the class. We have counted and said there are 16 new technologies. Next slide, please. Next slide. Right. There are 16 new technologies we have to learn. Now, personally, I am very happy. None of these things fear me. Right? Because artificial intelligence, I became aware of it right in Bombay in 1987. I went and sat for some classes in artificial intelligence in 1987. In 1993, I went for a robotics course. That sort of a robotics knowledge. And recently, in our fellowship class, we have taken 12 papers and we have done the review of the 12 papers. And then I told my students, try to review 100 papers. You have 20 students, each of you take 5 papers and try to review 100 papers. I thought they will not do. I sat on one Saturday and tried to download 100 papers. When I myself downloaded 100 papers, I thought 16 technologies are there. Are there papers on these 16 technologies? I got at least 16 into 3, 48 papers. I downloaded and kept those 48 papers. So exploring the technology, the basic material is with me, and I am sure I am going to make my students, both fellow students as well as the PGDA students, go through these technologies and do that basic learning process. Right? So what I assure you is, it is not difficult. Right? As an industrial engineer, learning these technologies is not, I personally know already entire big data analysis. All Hadoop and all is a very simple thing for me to explain. Good. Yes, what I would like to conclude is, there are changes in the landscape relevant to this particular thing. Curriculum needs to change, that's the effectiveness IE, that's what I said. For increasing effectiveness IE, we have to do certain things. And what is effectiveness IE? Significant productivity improvement and cost reduction. Okay. Now, as Mr. Pankaj Agarwal, he has said 250 crores, right? How to scale up to the entire country? The challenge of industrial engineering is how much I can contribute to the cost reduction in the country, right? 1915, there is a paper by Harvard faculty in the area of scientific management, and he wrote in that particular paper in 1915, right? Scientific management in practice is the paper title. He wrote that companies are unwilling to give the total numbers. Companies are more willing to give individual project. In this project I got this benefit. But he said, very interesting at that time, he said, one automobile company at that time in 1915 got a cost reduction of $750 in 1915, and somewhere he has written, they were selling the car for a price of $2,950, let us say. They reduced that price to $2,150 or something like that, that's $750. They were making losses at $2,950. They started making profit at that $2,150. Unfortunately, I don't think there is any other example in the literature which tells you what industrial engineering has contributed to the company of this nature. We have so many executives from the NITIE who are working in the industries, but I really appreciate Pankaj Agarwal for giving that particular point that 250 crores is the savings that was created. I really hope many more such examples come to light. Right. So what I would say is, when many ideas are there in what is industrial engineering, and I would say it is industry expansion engineering. Cost reduction facilitates price reduction, and that gives rise to expansion of industry. IE therefore is industry expansion engineering. New products create new industries. That innovation of new products, whenever a new innovation comes, it creates a new industry, and IE expands those industries. So as and I see a new product has come, it is my job. Initially, let us say 1,000 people have bought, manufacturer is happy, right? But an industrial profession should be happy only when the entire world people are able to use. How do I expand that what was bought by 1,000 people to whatever crores, only 9 billion or 7 billion, we are talking of the population of the world. Each and every successful item it should be able to scale to that sort of a level, and that comes only through cost reduction. That's what yesterday Professor Premwat has said. I must have a passion, I must have pride in what I am doing. If I am the man who is response, efficiency and cost reduction, I must have the pride in that. Yes, I will do something and contribute to the society. Right? I thank all the participants. I thank the organizers for giving the opportunity to me to share my thoughts. I thank our Director Karunajan especially for giving the opportunity. Thank you all.